a few people send me an email and just want to double check a couple of things. So let's go ahead and do that. So let's make sure we're all on the same page here. Can somebody tell us what a polynomial is or describe a polynomial for us? Yeah. It usually has more than two terms, but it doesn't have to. Polynomial means many terms. Okay. It usually has two or more. Okay. So we'll say something like this. This is pretty informal. A bunch of terms with powers of x. And I'm going to add one more thing. Powers of x isn't quite enough. They need to be positive powers of x. Positive powers of x. So these examples right down here, these are all polynomials. Okay, you'll notice that none of them have negative exponents. Okay, yeah.
Can't the exponent be 0?
Wow, this is what I was hoping for. Okay, so I left enough space here to write the word positive. Okay, and usually they are positive. You'll notice that each one of these is positive. That one has a 1 on it, right? But Raymond brings up a good point. Does that have a power of x? Doesn't even have an x, does it? Could we write one? Could right here, could we write x to the 0? What is x to the 0? What did we learn yesterday when we were reviewing exponents? Any number to the 0 power is going to be 1, right? Okay. So would that be okay there? So maybe we shouldn't say positive. Maybe we should use another word for that. What's the only group of numbers we're leaving out? Yeah. Excellent. Okay, remember we went over this last week? Non-negative. Now, that's kind of a fancy math word, but that gets at what we want. It can have powers of x that are 0 or bigger. Does that take care of it? And so, I mean, we all know that's a polynomial, right? Is this okay? Would this be part of a polynomial? Oops. X to the negative 1/3? Not with the negative. What about x to the 1/3? Is that a polynomial? Isn't that the cube root of x? Good. Usually, thanks. Polynomials are the ones that we're going to deal with are going to have regular old whole number integer powers, okay, that aren't negative. Okay, that's usually what we're after. That's usually what we're dealing with. So just keep that in mind. All right. What are terms? How do we tell one term from another? They're separated by something. What are they separated by? I think this was actually mentioned in a previous section. Yep. Separated by, I'm going to put plus or minus. Okay, technically, again, it's just addition. Okay, but separated by a plus or minus. So there's a term, and there's a term. Okay. What is a coefficient? Yep, very good. The number in front of x. Okay? All right. What is the degree? Okay. So for a term, it's the same as the power. For the whole polynomial, what is it, Lynn? The highest power. Okay, so it's the highest power. So if I were to take a look at this polynomial right here, that one right there, the degree of this one is 0. The degree of that term is 1. And what's the degree of this term right here? This one's going to be 3. Okay? What's the degree of the whole polynomial? The whole polynomial is degree 3. And I just realized I have a typo. Where's my typo? That should be a y. Okay? Sorry about that. Good there? Okay. What order do we normally write polynomials? Largest to smallest. So what do we call that? Largest to smallest? Descending. Okay. And which can we do with polynomials? Add, subtract, multiply, or divide? All of them. You can do every single one of those. Okay. The ones that we're going to focus on in this particular section are add, subtract, multiply, and divide, and mostly on multiply. Okay. Any questions? Okay. So let's take a look at, and I've got that one corrected there. Let's take a look at this one right here. And again, I didn't have anybody ask about this, so I'm going to do this really quickly. I just want to make sure you're cautious on these. When you're doing a problem like this, you want to be careful and make sure you distribute through. A lot of people will do this. Is that right? No, you've got to make sure that you distribute that. You're subtracting every one of those terms, so you change the sign of every one of them. And then how do we tell if they're like terms? Same variable, same base, and same exponent, right? So I can put the cubes together, so that's going to be 3x cubed. I can put the squares together. There aren't any other squares, so that's just going to be minus 7x squared. Done with that one. There are a couple of x terms together. That's going to be 11x. Done with that one. And then I've just got that plain old 1 there. And that would be the answer. Okay? Addition is a piece of cake because all you're going to do is you're just going to take each one of those, distribute a positive through. Does that change anything in here? Doesn't change anything. And then you're going to collect like terms. Do I need to finish that one? Okay. Let's take a look at this because we're going to spend most of our time doing the opposite of what we're going to do right now. We're going to multiply each one of these terms by each one of those terms. That's how you multiply polynomials. Some of you may have learned the word FOIL for first, outside, inside, last. And that's totally fine, but that only works with binomials. It only works if there are 2 terms here and 2 terms here. The idea behind polynomial multiplication, and we'll do one in a little bit, that has more than 2 terms is you take this term right here and you multiply every one of those. So it gets its turn being distributed through to every one of those, and then it's this one's turn. So we're going to end up with, this is a 6x squared from here. Then we're going to get plus 3x. And then it's the negative 5's turn. So minus 10x, and then minus 5. And then again, we collect like terms. So 6x squared, this is minus 7x, and this is a minus 5. Okay? It does that if I circle too quickly. Any questions? Okay. I did have somebody ask about these formulas right here. So the book actually does this one also. It does u plus or minus v quantity cubed. This doesn't come up very often. Powers of binomials are important, and we'll actually study those a little bit more in depth later on in this class. But these are ones that you ought to take time to memorize because we're going to undo these very formulas right here. So if I have u minus v and then times u plus v. So this minus that and this plus that. We end up with u squared minus v squared. If we have u plus v quantity squared, we end up with u squared plus 2uv plus v squared. And if I have u minus v quantity squared, I end up with u squared minus 2uv plus v squared. Okay. And we're going to take a look at why they work out the way they do, at least on 2 of these. So let's take a look at this one right here. If I were to take the u and multiply it by each one of those, I first get u squared, then I get plus uv, right? What happens when I multiply the negative v through here? Negative uv, I'll write them in the same alphabetical order, and then I get minus v squared. Okay, those middle terms, and this will happen every time, these two are the same factors, okay, except for the plus and the minus. Those middle ones will cancel out. So I end up with u squared minus v squared. Okay, this has a fancy name. Anybody know what this is called? This is called difference of squares, and we're going to see it again in just a second. Okay, so that's called the difference of squares. Difference of 2 squares. Here are the factors that it came from. If we have u plus v quantity squared, it literally means u plus v times u plus v. It looks very similar to this right here, except for that one negative. So when I distribute the u through, I get u squared, then I get plus uv. Now it's the v's turn. So this is going to be uv and v squared. Now take a look at the middle terms here versus the middle terms right here. What's the difference? Yeah, they don't cancel to be 0, they actually double up. There are two of exactly the same thing. So I get u squared, I get two of these guys right here, and then the v squared. So you'll notice both of those being positive makes the v squared positive, and it makes it so those double up. That's why we get different answers for the two of these. And the only difference between this one and this one is these two middle terms would both have a what? Well, they're positive here. What would they be since this is u minus v times u minus v? They'd both be They'd both be negative uv, negative uv. This would be a plus v squared, and that would be a plus u squared. You get the same thing, except for those two middle terms are now negative. They're still the same, so they still double up. So we get minus 2uv. Any questions? Raise your hand if you've seen those before. No problem. Okay, excellent. All right, let's take a quick look at how we can apply these. This is why you want to take the time to memorize these patterns, because it will make multiplying things like this much, much quicker. So if I were to do this one, I recognize this is 2x minus 3 and 2x plus 3. This minus that, this plus that. So this is going to be that squared, which is going to be 4x squared. It's going to be 9, because that's 3 squared. And what do I put in between here, a plus or a minus? I put a minus. That quick, I'm done. I don't have to go through all the multiplication. I notice that this is the square of a binomial. So I'm going to end up with, it's going to start with that squared. That's going to be 9x squared. It's going to end with this squared, so that's going to be plus 25. And here's how you get the middle term. Multiply the two of these together. That's going to be 15x. That's what each one of those are, and there are two of them. So what's twice as much as 15x? 30x. So plus 30x. And again, if it's plus, they're all positive. If it's minus, the middle term is going to be negative. That's the only difference. So we're going to square that. It's going to start with a perfect square of 10u, so that's going to be 100u squared. It's going to end with a perfect square of v, so that's going to be v squared. And then I multiply the two of those together. That's going to be, that's going to be 10uv. So what's that middle term? 20uv. And the sign is? Sign's negative. Okay? All right. Any questions? Okay. I have a little confession to make. I think I mentioned I've taken probably 60 math classes. I've taught math for 18 years, and I just learned about this special type of product a couple of years ago. I hadn't seen this technique before. Okay? So let me show you how most of the time we would multiply two binomials with three terms. The idea, again, is every term here gets its turn being multiplied by each one of these. So if there are 3 terms here and 3 terms here, I'm going to end up with 9 terms altogether. I'm going to do x times each one of those. So that's going to be x squared plus xy plus 3x. Okay, I'm done with the x. Now it's going to be the y's turn. So this is going to be plus y squared, plus xy. Plus y squared, and then plus 3y. And then it's going to be the negative 3's turn. And I do need to distribute through the negative, so that's going to be negative 3x minus 3y, and then minus 9. And then what would I do with all 9 of these terms? Go through and collect like terms. Okay, so that's how you multiply. There's no FOIL that works for that. You've got to understand the idea for polynomial multiplication. Okay, but this is kind of cool. Okay, that's one way to do it, and that's going to produce the right answer. In the book, they showed you how to do this. Let's put this in parentheses. Let's think of that in brackets, that in parentheses, and that in brackets. And then we're going to think of it as x plus y minus 3 and x plus y plus 3. And let me say that again. Does that sound a little bit familiar based on what we talked about up here? X plus 3 minus y, x plus 3 plus y. Isn't that kind of like a difference of squares? Yeah. So it's going to be x plus y squared minus 3 squared, which is 9. Now, I'm still not done, but this is a little bit better. Because look at this big long mess, and I'm still not done. I'm almost done here because this is something we know how to square pretty quickly if we memorize those formulas. That's going to be x squared plus 2xy plus y squared minus 9, and I'm done. Now, you don't have to use that technique, but if you practice it just a little bit, there's going to be a point later on in this class where being able to do that is going to save you a lot of work. I mean, look how much time it took to do that. And that's assuming we got all these numbers right. We still have to go through and combine them. So if you make one silly mistake, you might not get the right answer. Okay, any questions? Okay, all right. Just like with most things in math, once we learn how to do something, we're going to learn how to undo it. Okay, we're going to learn how to undo it. So the opposite of multiplying polynomials is called, anybody? Factoring. Very good. Thank you, Tony. Okay, it's called factoring. Let's see. Oh, where'd my numbers go? All right. Told you this happens sometimes, didn't I? I'm going to close down this program and then open it up again really quickly. Here we go. Okay, so undo, it's called factoring. And here's why we'd want to learn how to factor polynomials. A lot of times it simplifies what you have to write down. Many times we're going to use it to help solve an equation or something. And a lot of times it's very useful in higher math. So there are a couple formulas that you definitely need to know. Difference of squares, okay, perfect square trinomials, and difference in sum of cubes. Okay. So in order to do these well, you need to be able to recognize some numbers. So if we write down some perfect squares, squares of integers, 0 is a perfect square, but we don't use it very often. Okay, 1 squared is 1, so we're in good shape there. 2 squared is 4. So if we count by perfect squares, what's the next one? 9, 16, 25, 36, 49, and so forth. Okay, it would be good if you memorize these maybe all the way up to, let's see, after this it's going to be 64, 81, 100, 121, 144, 169, 196, and 225. Okay, those would be good ones to recognize. Okay, at least up to 144. I mean, most people memorize their 12 times tables. Okay, and as far as perfect cubes go, 1 is a perfect cube. 8. 8 is the next perfect cube. Think 2 cubed. 3 cubed is 27. Hop's got it. 4 cubed? 64. 64 is kind of interesting because you'll notice it's in both lists. It's a perfect square of 8 and it's a perfect cube of 4. Okay, and then perfect cube of 5. 125, perfect cube of 6, it is 216. Okay, again, I would know about to right there. Okay, these numbers you definitely ought to recognize as perfect cubes. Okay, these are basically the formulas that we wrote up above in reverse. So if you see a difference of squares, and again, sometimes people memorize this with the negative in the second place. I wouldn't do that, and I'll show you why in just a second. So this is going to be u minus v and u plus v. So if I see a difference of squares, it's got 2 terms. That's a perfect square of 2, and that's a perfect square of 9. And it's got a minus right there, right? So it is a difference of 2 perfect squares. So it's going to be 2x minus 9 and 2x plus 9. It's that simple. We're all finished right there. it's got two terms. It's a difference. It's got a minus in there. That's a squared. And what is that? 116. That's a perfect square of? Perfect square of a, perfect square of 1/4. So this is a minus 1/4, and this is a plus 1/4. Okay? And that quickly, we're done. We factored those. Okay? Any questions? Okay. Perfect square trinomials. If you see something that fits this pattern right here, so it starts with a perfect square of u, ends with a perfect square of v, and the middle term is that variable times that variable multiplied together and then doubled. So it's twice as big as the two of those multiplied together. Then it's going to be u minus v quantity squared. And the only difference between the two of these is this has a minus, this has a plus, so this would be u plus v. So again, let's take a look at how to spot that pattern. So it's got three terms. Remember, we're talking about trinomials. Is that a perfect square? Of what? X. Is that a perfect square? Of what? 5. Multiply those together, you get 5x. If you double this right here, is that the right middle term? It is. So we're going to write down that variable and that number, put a square on it, and what goes in between here, a plus or a minus? It's going to be a plus. It's the same as that sign right there. So it's going to be u plus 5 quantity squared. Okay? Let's take a look at this one. Perfect square of 5y. Perfect square of 3. If you multiply those together, you get 15y. If you doubled that, is that the right middle term? It is. So we write down 5y, we write down 3, put a square on it. What sign goes right here? It's going to be a minus. Okay? All right. And then these other ones down here, this sum and difference of cubes. Really, you would have no hope of getting these formulas if you didn't have them memorized. Okay? I have to think myself, how would I derive that? How would I figure this out from scratch? Okay? So these are just worth memorizing because you will see these over and over and over again. So you'll notice that it has two terms and they're both perfect cubes. So it's going to be u minus v. And this is why I like to put the negative first. Okay? If you learn to factor a difference of squares by putting the plus first, I wouldn't. And here's why. If you have two terms and there's a negative in there, in between the two of them, a minus, then make the first one minus, because in every one of these formulas, this one, and this one, there's only one negative formula, or one negative in the formula. And if you've got a minus here, make the first one negative, so that one's a minus, and then everything else is a plus. And this middle term is just u times v. And again, if you wanted to stick around afterward, if you wanted to come ask me, I'm happy to show you how to derive this, why it works this way. Okay? On this one, if it's u cubed plus v cubed, so this is a sum of two cubes. Again, if this is minus, make the first factor negative. If that's minus, make the first factor with a minus. If this is plus, make that one with a plus. And that makes it so the negative has to go in the middle of the second one. Again, there's only one negative in each one of these formulas. It's got to go in the middle of one of them. If it doesn't go in the middle of the first one, it's got to go in the middle of the second one. And it looks like that right there. These are weird formulas. They do take practice, but they are well worth figuring out. Okay? So here's how we check. This has two terms. Is the first one a perfect cube? Of what? X. Is the second one a perfect cube? Of what? 3. So it's going to be x minus 3. Take those two and just put them in a little binomial with a negative in between them. A minus there. And then this one is going to be a perfect square of the first one. So it's going to be x squared. It ends with a perfect square of that one. So that's going to be a 9. And then all I do is I literally just take them and multiply them together. So that's going to be 3x. And my question for you is, what sign goes in front here? Is it a plus or a minus? It's a plus. Why does it have to be a plus? We already used the negative right here. See what I mean? Okay. So let's take a look at this one. Two terms. Is that a perfect cube? Of 2 and x. Is that a perfect cube? Yep, it's in our list over here. So we write down 2x and 5, make a little binomial of it. What goes in between here? It's going to be a plus. Whatever this sign is, that's the sign that goes in between the first two terms. And then I take this one. It's going to start with a perfect square of that. That's 4x squared. It's going to end with a perfect square of that last one. So that's going to be 25. Multiply them together. 10x. What goes right here? It's got to be a minus. Why does it have to be a minus? Because there's got to be one negative, one minus in each one of these formulas, and it didn't go here, so it's got to go in the middle of the second one. Any questions there? Okay. Let's flip that over. Okay, those are special factoring formulas. You should memorize those. Those are going to come up all the time. If you've got to memorize, that's going to make life easy. Okay? Those aren't the only ways that we factor. Okay? A lot of times we'll factor stuff like this. And on a simple problem like this, we use something called guess and check. The only way to make an x squared here is to have an x and an x. The numbers that go here and here have to multiply to be 3 and combine to be 4. Multiply to be positive 3, and I like saying the sign. Multiply to be positive 3 and combine to be positive 4. What will do that? Positive 3 and positive 1. Okay, let's double check. Do they multiply to be positive 3? Yep. And when I multiply here and here, I'd get a 3x plus a 1x. Would those combine to be the right middle term? They would. Okay, so that's the correct factoring. So let's do this one. If it starts off with a 1 as a coefficient, 1x squared, 1m squared, 1y squared, whatever it is, okay, guess and check is the easiest way to go. The question is simply what multiplies to be positive 30 and combines to be negative 11. Negative 5 and negative 6. They both have to be negative so that they multiply to be a positive and combine to be a negative. That's the right answer. Any questions? Okay. What's different about this one? There's a coefficient other than 1. That makes figuring out what numbers are going to go here a little bit more difficult. It could be 6x and x. It could be 2x and 3x. Or we could switch these around depending on what numbers we put here and here. Okay? If you're very good at guess and check and you know how to factor this and you're really good at factoring trinomials, that's awesome. But if you haven't seen this technique, I want to make sure that everybody knows how to do this. The thing I like about this technique is it will tell you whether or not it factors, and if it's prime, you can figure that out pretty quickly. You don't have to try 6 different ways of factoring before you go, oh my gosh, this doesn't have an answer. Okay? So here's how it works. I'm going to take that number and that number right there, including the sign, and I'm going to multiply these together. What do I get? I get negative 30. Raise your hand if you've seen this technique. Okay, very good. I'm then going to look at this number and that number right there. I'm going to look at negative 30 and negative 13, and I'm going to ask myself the same questions I asked before. What multiplies to be negative 30 and combines to be negative 13? Multiplies to be negative 30 and combines to be negative 13. Logan. Okay, 15 and negative 2. Do they multiply to be negative 30? Yes. Do they combine to be negative 13? 2 and negative 15, okay? That's going to be right. Another option, and this is why this one's kind of interesting. Let's say we did this. They multiply to be negative 30, and a 10 and a 3 would normally make 13, right? But what do these add up to? Negative 7. Is there any way those are the right numbers? They're not, okay? So I call this technique trinomial grouping, okay? So we're going to use these two numbers, and here's what we're going to do. I'm going to rewrite this, 6x squared. I'm going to rewrite the negative 13 using those two numbers right there. I'm going to write minus 15x plus 2x minus 5. So you'll notice that the only thing that I did different was I rewrote the negative 13 as two separate numbers. But this is still the same polynomial, isn't it? Okay. Any questions? Okay, does anybody know what we do from here? If you have more than 3 terms, you have to factor using a specific technique. Yeah.
Don't you have to take out some numbers?
You do. You have to take out some numbers, and you have to do it in the right order. We're going to actually group these together. I'm going to think of these two as a group and these two as a group, and I'm going to factor them separately. So what can I take out of 3x squared minus 15x? Is there a common factor that I can take out of each one of them? Okay, so I can take out a 3 and an x. And if this hasn't been mentioned before, we always want to take out the leading sign. So if it starts with a positive, we're going to take out a positive. That's going to leave me with a 2x and a minus 5. Now take a good look at this second group right here. I have to take something out. I have to factor something out. I have to divide out a number and or a variable. Hop, what can I always take out? I can always take out a 1. Now, please write this. A lot of people will just do this. Please don't. This looks like a big, long multiplication problem. Take out the leading sign, write that plus there. It's important. We took out a positive 1. It's very important. Okay, now notice, I have this term right here and this term right here. Remember, terms are separated by pluses and minuses that are not inside parentheses. One term here and one term here. Do they have anything in common? They have a 2x minus a 5, and they have a 3x plus a 1. Everybody good there? Okay, that's it. That's the answer. Now, that took about 4 minutes to explain. If you've seen that before, you're probably in pretty good shape. If you haven't, the nice thing about this is, again, what if we couldn't find any answers? No numbers that multiply to be negative 30 that combine to be negative 13. Does it factor? Nope, it doesn't. And this way, even though it's a fair amount of writing, for a lot of times, if you get really good at this, it's faster than guess and check. Okay? Any questions? Okay. All right. Let's take a look at this. I've got some rules of factoring. If you go through these 5 steps, now it's not like you have to go through, okay, step 1, check that. Step 2, check everything on that, and so forth. It works like this. The first thing that you always want to do when you're factoring is you want to start by factoring out the greatest common factor, or we call it the GCF, along with the leading sign. So if we've written it in descending order and it starts off with a negative, which a lot of times it won't, okay, but if it does, factor out the leading sign as well. Usually that's going to make it easier, okay? Step number 1, don't forget it. It's going to make your life easier. Whatever the problem is, taking out the greatest common factor will make it easier to complete, okay? The next thing you do is actually look at step 2, 3, and 4. You count the number of terms, and step 2 is for 2 terms, step 3 is for 3 terms, and step 4 is for 4 terms, okay? So if you have 4 terms, you skip steps 2 and 3. Go right to step 4, okay? But if it does have 2 terms, there are only 3 ways that we're going to factor 2 terms. Difference of squares, difference of cubes, and sum of cubes. And you just need to know the formulas. So if you have the difference of squares, it's going to be, in this case, write the minus first, u minus v, and u plus v. Difference of squares. Difference of cubes. Perfect cube minus a perfect cube. U minus v, again, write the minus first. Everything else is positive. Don't put a 2 on that guy right there. Okay, remember, it's just the 2 of them multiplied together. And then what's the nice thing about, if you know the formula for difference of cubes, how does that relate to the formula for sum of cubes? It's exactly the same except for what? Yeah, the sign. So this is going to be u plus v. This is going to be u squared. Remember, it's always in the middle of one of those 2 factors. And there we go. Oh, darn it. I messed up my tabs. Taking a look at the next one. Okay? All right, so those are the only 3 ways that we're going to use to factor 2 terms. If it has 3 terms, okay, it might be a perfect square trinomial. If it is, there's the formula for if it's a plus in the middle. What's the only difference between the formula if it's a minus in the middle? U minus v, okay? And again, perfect square here of u, perfect square here of v. Multiply u and v together and double it. That's got to be the middle term, either with a plus or a minus. Okay? Now, I'm calling this the easy type of trinomial. What makes this the easy type of trinomial? Coefficient is 1. Okay? If the coefficient is 1, you're going to use guess and check. Okay? If it's not 1, a more complicated number like 6 or 12 or something like that, okay, then you're going to use that trinomial grouping technique that we talked about above. You're going to multiply a times c. You're going to figure out what numbers multiply to be that number, combined to be that number right in the center there. Any questions? Okay. If there are 4 or more terms, we group the terms. We factor by grouping. 4 or more terms, you're going to factor by groupings. Okay? You're going to group them and take out a greatest common factor within the groups. And really what we're after is we want to make it fit a pattern like this right here. Okay? That's why we group. We group it to make it look more familiar. And then the last thing, always factor blank, and don't forget to include all the factors in the final product or final answer, we'll call it. Although I do like product. Got that part. Always factor, have you heard this phrase before? Factor completely. You want to make sure that you have factored everything. Okay? All right. Any questions? Okay. Here's what we're going to do. Factoring is really, really important. Okay? So, I'm trusting that everybody here is a good student and you did go home and you read section P3, and that's good. Okay? Raise your hand if you're done with P3. Okay, very good. Tammy. Just kidding. Okay, here's what I want you to do. If you've already read it, hopefully we covered all the ideas. I know we touched on each topic that somebody emailed me about. I'd like you to go home, and I'd like you to, if you haven't finished reading it, make sure you read it. And if you're not done with P3, try and get done with P3 tomorrow. We're going to come back tomorrow, and we're going to do these problems right here. Okay, and I've got asterisks by some of these, and some of these are easier than what's in your homework. Some of them are a little bit more difficult. Okay, we're going to come back tomorrow. We'll do that, and then I think we'll get started on P4. Okay? If you're done with all that and want to start reading P4, but factoring is really important. Make sure you know those rules. If I didn't answer your question today, make sure you ask a question on it tomorrow so we're clear on how to do this. Okay? And if you haven't seen very much factoring, if this is like, oh my gosh, please send me an email so I know that we've got an issue we need to deal with. Okay? All right.